Hi everyone, this is a worked example for a problem from section 2.2, some basic functions. We're going to go through graphing a piecewise function. And in particular, we're going to graph number 52 from the textbook, this function q of t, which is a piecewise function. It's t squared if t is less than or equal to -1, and it's the cubed root of t if t is bigger than -1. Okay, so what I found is that the thing that people struggle the most with piecewise functions is understanding what this notation means and how to read it. And so I want to go to a real life example before we go into math. And so what I'm going to pull up is the academic services page. So if you don't know about the academic services at Brandeis, you should. The folks in this office are fantastic. They just do a fabulous job. If you ever need help figuring out your schedule, or anything at all academic, if something's going difficult there, you're having difficulties in your life and it's affecting your academics, these are the people to talk to. They're fantastic. Okay, why do I bring this up in piecewise functions? So if you wanted to access, make an appointment with one of these academic advisors, it depends on your last name, right? So you'd figure out your last name. My last name is Tori, so I would have to say, oh, my last name starts with a T, and so I'm gonna contact my last name starts with a T, which is in this interval from S to V. So I would use Katie Dunn as my advisor. She's fantastic. I'm happy to meet with Katie. Okay, so this is an example of a real live piecewise function. Okay, where you have people are contacting me all the time. I try to turn off these notifications and I fail. Okay, right, you have all these different ranges of the alphabet, and depending on which range of the alphabet your last name falls into, that's how you would choose your advisor. Okay, a piecewise function in math is the same kind of idea, right? So what this is telling you, so just like in the example with the academic advisors, this part over here is like the range of the alphabet, right? So it's saying, depending on the value of t, I'm going to tell you which function to use. Okay, so for t values that are less than or equal to -1, you're going to use the function y equals t squared. And for t values that are bigger than -1, you're going to use the y value, the function y equals cubed root of t. Okay, if we were going to write out the example with the academic advisors, right? I don't remember the exact distinction, but we would say it would look something like advisor of name, and I don't have a lot of space, so I've moved my equal sign down here. You'd have this curly bracket and lots of different advisors, right? So you'd have Brian Koslowski if your name is in A through C, right? You'd have Aaron Norton if your name is D through F, something like this. But go to their webpage, don't use this because that's not correct. But that's what it would look like, right? So depending on what your last name is, you would choose your advisor. Depending on what the t value is, you use a different y function. Okay, so when we're graphing this, so first we need an axis. Oops, I'll probably try to center this a little bit better. Maybe I will move it down here so that I can use this whole space. Okay, and oops, I grabbed that P. And so this is my T axis because I'm using T instead of X over here as my input variable. So T axis is on here. And so this is saying for all T values that are less than or equal to -1, I'm going to use this, and T bigger than -1, I'm going to use this. So -1 on the T axis is an important point. So let's make sure we graph that. I'm going to make this nice and big, and maybe some other values. And 0, and then 1, and 2, and 3. And then we have y values, 1, and 2, and 3. And -1, -2, -3, like this, okay? And so what this is saying is, it's saying if t is less than or equal to -1, we're going to use the function y equals t squared. So the first thing I like to do is plug in the endpoints. So when t equals -1, I can plug it in. -1 squared is +1. So I know that at -1, the y value is going to be +1. And I'm going to draw a dot there. okay? We're gonna have some open circles too, so watch out for those. This one we're gonna use a closed circle because the closed circle means that the function actually is that value at that point. And we know that we are actually using that value at that point because of this less than or equal to is different from this greater than that doesn't have the bar meaning equals underneath it, right? So this is strictly bigger than, this is less than or possibly equal to. So also equal to -1, we use this value t squared to get -1. Okay, now the function y equals t squared, right, is the parabola, right? It looks like this, it goes through 0, 0 like this, but we're only using that parabola when we have these values t less than or equal to -1. So we're only going to draw this function out this way. It's nice to have another anchor point. So -2 is less than -1, so we're going to use the t squared. -2 squared is 4, which is already off my map. Like that, okay? So we're going to draw in this parabola, right, which again would normally continue down here. It would hit 0, 0, it would come back up and have this nice parabola, except that we're only taking this part of it when t is less than or equal to -1. Okay, and then it goes forever in that way. Okay, so for what do we do for the t values that are bigger than -1, right? Anything over here, anything that's bigger than -1, which means to the right of it, we're going to use cubed root of t. Excuse me. So cubed root of -1. So remember, the cubed root is the number that you multiply by itself 3 times to get the value out. -1 times -1 times -1 is -1. So cubed root of -1 is also -1. Here, though, we're going to draw an open circle. So you do want to know what that endpoint is. You can just plug it in, -1. Cubed root of -1 is -1. But because, again, we don't have that equal sign underneath here, it's just strictly bigger than, we draw an open circle, okay? And then we keep drawing. So the cubed root function, that's the function that has this sort of S-looking curve going this way, right? So we're going to draw that in for the values of t that are bigger than -1. So that means on this side over here. So to the right of it, excuse me. So we're going up, it passes through 0, 0. It's also going to pass through 1, 1, curving it back around the other way. And the next interesting point that happens, it's going to hit y equals 2, which is at t equals 8. So it's like way off the graph over there. So we don't really hit a nice integer point. Again, on the graph that I've drawn. Okay, so this is what it looks like. So again, let's come back to this t bigger than -1. That does not mean that we start at 0. You have to start right at that endpoint, because even for -0.99999999999999999, we want that graph here, right? So anything that's even the tiniest little smidge bigger than -1, it needs to be on the graph. And that's what this notation means. It means actually at -1, you've got a hole, there's a little missing piece there, but everything right up into it is going to be on that graph. Okay, so this is our graph for y equals t squared if t is less than or equal to -1, and cubed root of t if t is bigger than -1.